Hi, my name's Amanda and I'm a pharmacist. Today I'll be talking about a type of pharmacy calculation called concentrations. And if you find this video useful, please press the like button, subscribe to my channel, and share it with others who may find it helpful too. Thanks, I really appreciate it. So we'll start with a definition. So what are concentrations? Concentrations are the strengths of liquid and topical products. And more specifically, a concentration is the amount of active ingredient per the total weight or volume of the product. So a formula for determining concentration is concentration equals the amount of active ingredient per, which means divided by, the total weight or volume of the product. And there are a few different ways that a product's concentration can be expressed. It can be expressed as a drug strength. This would be something like amoxicillin suspension, 250 milligram per 5 milliliters. That's the concentration. As a percentage, this will be something like 5% dextrose IV solution. 5% is the concentration of that solution. Or it can also be expressed as a ratio. This will be something like epinephrine 1 to 1,000 injection. The drug strength and percentage are the more common ways that a product's concentration is generally expressed. Ratio is not as common, but we're going to talk specifically about each of these now. So first we'll look at concentration as a drug strength. Concentration as a drug strength is the amount of active drug per a given amount of drug product. And remember, we're talking here about liquid and topical products. So for drug strengths, there are many different units of measure. It's generally something per something. So it can be milligrams per milliliters, micrograms per milliliters, units per gram, grams per milliliters, and so on. There are many different units of measure. Here are some different types of drug strength concentrations. There are amount of drug per dosage unit. An example of this will be something like albuterol nebulizer solution unit doses. These come in 2.5 milligrams per 3 milliliter for each vial. There's also amount of drug per quantity of liquid. An example of this would be amoxicillin suspension, 250 milligrams per 5 milliliters. Or there are amount of drug per quantity of a topical product. This will be something like nystatin cream, 100,000 units per gram. Now we'll look at some drug strength concentrations questions. Question number 1. How many milligrams of prednisolone are in 100 milliliters of prednisolone 15 milligram per 5 ml solution? The way we're going to solve this is we're going to set up equivalent fractions, cross multiply, and then divide. And if you've seen any of my other pharmacy calculation videos, you know that this is a very common method for solving pharmacy math problems. So we know the concentration of our prednisolone solution is 15 milligrams per 5 milliliters, so that'll be our first fraction, 15 milligrams per 5 mLs, equals X milligrams, that's what we're looking for, is how many milligrams, per 100 milliliters. So the other fraction is X milligrams per 100 milliliters. And X here is the variable representing the answer we're looking for. Next, we're going to cross multiply. So 15 milligrams times 100 milliliters equals 1500. Then we're going to divide to solve for X. So 1500 divided by 5 equals 300. So that's 300 milligrams are in 100 milliliters of prednisolone 15 milligram per 5 ml solution. And also note here that our numerators, which is the top number of the fractions, they have to be the same units, and the denominators have to be the same units, which are the bottom numbers of the fractions. So, and it is that way, the 15 milligrams, and then we have X milligrams, and we have 5 milliliters and 100 milliliters. So that always has to be set up for these equivalent fraction method to work. Okay, drug strength concentrations, question number 2. How many milligrams of amoxicillin are in 50 milliliters of amoxicillin 400 milligram per 5 ml suspension? We're going to solve this one the same way. We're going to set up equivalent fractions, cross multiply, and then divide. So we have our concentration of the amoxicillin suspension is 400 milligrams per 5 mLs. That'll be our first fraction. We'll set that equal to X milligrams, that's what we're looking for, per 50 milliliters. We'll cross multiply, so 400 times 50 equals 20,000. And then we'll divide to solve for X. So 20,000 divided by 5 equals 4,000. So that's our answer. There are 4,000 milligrams of amoxicillin in 50 milliliters of an amoxicillin 400 per 5 suspension. Now we'll look at drug strength concentrations, question number 3. If there are 800 milligrams of acetaminophen in 25 milliliters of Tylenol suspension, how many milligrams of acetaminophen are in each teaspoonful? So we're going to solve this one the same way. We're going to set up equivalent fractions, cross multiply, then divide. So we know the concentration, 800 milligrams of acetaminophen per 25 milliliters of Tylenol. So our first fraction is 800 milligrams per 25 milliliters. And we'll set this equal to X milligrams, that's what we're solving for, as the milligrams, per 5 milliliters. It says in each teaspoonful, but 1 teaspoonful equals 5 milliliters. Remember, I said our units have to match, so we have milligrams and milligrams on the top of the fractions, milliliters and milliliters on the bottom of the fractions. So next we'll cross multiply, so 800 times 5 equals 4,000. Then we'll divide to solve for X. 4,000 divided by 25 equals 160 milligrams. So in each teaspoonful of Tylenol suspension, there's 160 milligrams of acetaminophen. Now we'll look at concentration as a percentage. So percent means per 100, or you can think of it as divided by 100. And there are 3 formulas for concentrations as percentages. There's weight per weight, or sometimes you may hear this as weight in weight. This means grams of drug per 100 grams of product, so those are both weight units of measure. There's weight per volume, or weight in volume, and I have a star here beside it because it is the most common one you'll probably see. And this means grams of drug per 100 milliliters of product, so it's a weight unit on the top and a volume unit on the bottom. And then there's volume per volume, or volume in volume. And this is milliliters of drug per 100 milliliters of product. So both are milliliters are volume units of measure. So you can think of the formula for concentration as a percentage as grams or milliliters of drug per 100 grams or 100 milliliters of the total product. And I'll give you an example here. If we have 5% dextrose solution, this means there are 5 grams of dextrose per 100 milliliters of solution. So 5 grams per 100 mLs. That is equal, you can say 5 per 100, which remember percent means per 100. So 5 per 100 equals 5%. And here's some common IV product abbreviations and concentrations. You'll want to memorize these and what they mean, because these are common abbreviations in pharmacy, especially in a hospital setting. So there's D5W. This means dextrose 5%. And this means that there are 5 grams of dextrose in 100 milliliters of sterile water. NS, that stands for normal saline, and that is 0.9% NaCl, which is sodium chloride. And this means a concentration of 0.9 grams of sodium chloride in 100 milliliters of sterile water. Then there's half NS, which is half normal saline. This is 0.45% NaCl, which is sodium chloride. And the concentration of this would be 0.45 grams of sodium chloride in 100 milliliters of sterile water. So now we'll look at some percentage concentration questions. We'll start with question number 1. How many grams of dextrose are in 250 mLs of D5W? So first, we have an abbreviation here of our product, so we need to determine the concentration of the product. D5W, that means dextrose 5%, so that means 5 grams of dextrose per 100 milliliters. So next we're going to set up equivalent fractions, cross multiply, and then divide. So our first fraction is going to be our 5 grams per 100 milliliters, and we'll set this equal to X grams. That's what we're solving for, is for the grams, per 250 milliliters. Next we'll cross multiply, so we'll take 5 times 250, that equals 1,250, and then we'll divide to solve for X. So then we'll divide by 100, and that equals 12.5 grams. So there are 12.5 grams of dextrose and 250 mLs of D5W. Now we'll look at percentage concentration question number 2. How many grams of NaCl are in 1 liter of NS? So this again is an abbreviation for a product. NS is normal saline, so first we have to determine the concentration. So NS is normal saline, and that's equal to 0.9% NaCl. And that means 0.9 grams of NaCl per 100 milliliters. So now we can set up equivalent fractions, cross multiply, then divide. So we have 0.9 grams per 100 milliliters. That's the concentration of the normal saline. We're going to set that equal to X grams. That's what we're looking for, how many grams per 1,000 milliliters. Notice in the question it's 1 liter is what we're looking for, but remember our units have to match. The numerator units and the denominator units of the fractions have to match. So since we have milliliters in our first fraction, it has to be milliliters in our second fraction. And if you've memorized your conversions, you know that 1 liter equals 1,000 milliliters. So now that we have that set up, we'll cross multiply. So we have 0.9 grams times, or 0.9 times 1,000, and that equals 900. Then we will divide to solve for X. So 900 divided by 100 equals 9 grams. So there are 9 grams of NaCl in 1 liter of normal saline. Okay, we'll look at one more percentage concentration question. Question number 3. How many milligrams of hydrocortisone are in 1 gram of 2.5% hydrocortisone cream? So this one we're going to set up equivalent fractions, cross multiply, then divide. We don't have to figure out our percentage because it's already given. And we just need to know what that percentage means. So 2.5%, that means 2.5 grams per 100 grams. So that's going to be our first fraction, and we're going to set that equal to X over 1 gram because we're looking for how much in 1 gram. And our unit for X is going to be grams. Remember, our fractions units have to match. What's on the top of one fraction has to be what's on the top of the other fraction, and the bottom units have to match as well. So first we're going to solve for X in grams, and then we'll convert it to milligrams for our final answer here. So we have our equivalent fractions set up, so now we'll cross multiply. 2.5 times 1, that equals 2.5. Then now we'll divide to solve for X. So 2.5 divided by 100 equals 0.025 grams. Now we need to convert to our correct units. We need to convert from grams to milligrams. And to do this, there are 100 milligrams per 1 gram, and we're going to multiply that by 0.025 grams over 1. Our grams cancel out because there's a gram on the top, a gram on the bottom, and we're left with milligrams for the top unit. So that's what we want. We want this in milligrams. So now we'll just do the math and multiply 1,000 times 0.025, and that gives us 25 milligrams. So there are 25 milligrams of hydrocortisone in 1 gram of the 2.5% hydrocortisone cream. Now we'll look at concentration as a ratio. Ratio strength describes a drug concentration in terms of a ratio. You can think of a ratio as a fraction with a colon. So like 1 to 200 would equal like 1 per 200. Ratio strength is generally 1 to something. So for example, 1 to 1,000, 1 to 2,000, 1 to 10,000. The formula for ratio strength to concentration is grams to milliliters. So for example, a ratio strength of 1 to 1,000 would mean there's 1 gram in 1,000 milliliters of solution. Ratio strengths are used to express concentrations of weak solutions when the percentage strength is very low. For example, a ratio strength of 1 to 10,000 is equal to 0.01%. So you can see how it can be a more convenient way of expressing a low concentration. However, ratio strengths are not very common anymore because they've been linked to medication errors. In 2016, the FDA required removal of ratio strengths from labels of single ingredient products. Now, you will still see those on multi-ingredient products. And this was to help prevent medication errors. Labels were changed to express drug strength instead of a ratio. So one of those products that was affected was epinephrine injection. So it comes in a 1 to 1,000 strength, and it also comes in a 1 to 10,000 strength. So you can see how those are very similar. Just, 1 0 is all that makes a difference, and they're very different concentrations, but because they look similar, that could increase the risk for medication errors. So these aren't as common, the ratio strengths, but they still are used somewhat. So we'll look at a couple questions with those. Ratio concentrations, question number 1. How many milligrams of epinephrine are in 10 milliliters of epinephrine 1 to 200 solution? So we're going to do these very similar to the other concentration problems. We'll set up equivalent fractions, cross multiply, and then divide. So a ratio concentration of 1 to 200 would be equal to 1 gram per 200 milliliters. So that's our first fraction, 1 gram per 200 milliliters. And this will set equal to x grams per 10 milliliters. Remember, we are solving for milligrams here, but we have to set it for grams because our top numbers of the fractions have to match. Our top units of the fractions have to match, and our bottom units of the fractions have to match. So we'll first solve for the x in grams, and then we'll convert it to milligrams. So now that our equivalent fractions are set up, we'll cross multiply. 1 times 10 equals 10. Then we'll divide to solve for x. 10 divided by 200 equals 0.05 grams. Now we'll convert to the correct unit. We're going from grams to milligrams. So we'll do 1,000 milligrams per 1 gram. That's how many milligrams are in a gram. Times 0.05 grams per over 1. Just to put it over something, because the number over 1 is equal to itself. So now our grams cancel out because we have a gram on the top of a fraction and one on the bottom, so those cancel. We're left with the unit of milligrams. Now we'll do the math and multiply 1,000 times 0.05, and that equals 50 milligrams. So there are 50 milligrams of epinephrine in 10 milliliters of an epinephrine 1 to 200 solution. You can also do the conversions of grams to milligrams by moving the decimal place. And if you know how to do that, that's great. But I like to set it up this way just so that you're sure that you're getting going the correct way, moving the decimal place. And that this is a good way to check because the unit that you're looking for is always going to be left on top and your other units will cancel out. Okay, ratio concentrations, question number 2. If an epinephrine product has a strength of 1 milligram per milliliter, what is the concentration expressed as a ratio? So first we need to convert to correct units for equivalent fractions. Remember, the ratio units are grams to milliliters. So first we'll convert milligrams to grams. Remember, 1 gram equals 1,000 milligrams. So we have 1 gram per 1,000 milligrams times 1 milligram over 1. And that our milligrams cancel because there's one on the top, one on the bottom. We're left with the unit of grams, and that is equal to 0.01 grams. So now we'll set up our equivalent fractions, cross multiply, and then divide. So our first equivalent fraction would be 0.01 grams per 1 milliliter. That's what we took from our ratio. Remember, it's grams per milliliter, so that's our ratio. And we'll set that equal to 1 gram per x milliliters. This one's a little different. We know that a ratio concentration is 1 to something. So our 1 gram is at the top and we're solving for the x milliliters on the bottom. So we'll cross multiply and divide to get our answer. 1 times 1 equals 1. Then we'll divide by 0.001, and that gives us 1,000 milliliters. that's not our answer because we're looking for a ratio. So our answer is, if an epinephrine product has a strength of 1 milligram per milliliter, what's the concentration expressed as a ratio? It's 1 to 1,000. So it's that the entire second fraction, 1 gram to 1,000 milliliters, or 1 to 1,000. Okay, now we'll just look at a summary and some key points to remember about concentrations. Concentrations are the strengths of liquids and topical products. And remember, as a formula, this would be the amount of drug per the total weight or volume of the product. There are drug strength concentrations. Remember, these come in many units of measure: milligrams per milliliter, grams per milliliter, micrograms per milliliter, units per gram, many different units of measure. Percentage concentrations, percent means per 100, and the units for a percentage concentration are grams or milliliters per 100 grams or 100 milliliters. So we have to be in grams and milliliters with percentages. And then there are ratio concentrations. Ratio generally means 1 to something, and the units for ratio concentrations are grams to milliliters. And the steps for solving concentration questions. First, we're going to set up equivalent fractions with correct units. Remember, our top numbers of the fractions have to match units, and the bottom numbers of the fractions have to match units. We're going to cross multiply, and then divide to solve for x, and then we'll convert our answer to the correct unit, what was asked in the question, if needed. That isn't always necessary. Thanks for watching. Please like and share this video with others who may find it helpful, and please subscribe to see more of my drug information videos. Thank you.